Welcome to another coding tutorial, and in today's video I'm going to show you how to create this mesmerizing set of hexagons. This tutorial is my take to recreate a piece by one of my favorite creative coders, Dave from Bees and Bombs. And this piece also has a very special place in my heart because the very first time that I recreated it was actually back in March of 2020, exactly 5 years ago. And that was also around the same time that I started to code again. And also it was when I actually started this channel and posted my very first video, which was about what is a creative technologist. And seeing my code from way back, I can see how far I've come, and I'm excited to share with you the more readable version today. Alright, let's start by creating a hexagon. And we're going to do that by actually creating 6 circles that makes up this hexagon shape. I'm going to declare a variable called sides and set it to 6. And then inside draw, we're going to use a for loop that goes through all the sides. And then inside the for loop, we need to find the x and y coordinates of each of the circle that is going to make up this hexagon structure. And we're going to use trigonometry by the equation r times cosine of angle and r times sine of angle. And how about we set r to be, let's do 100. And we want to calculate an angle that is spread out evenly around a circular shape, right? So to do that, we need to first divide 2 pi, which is 1 revolution of a circle, by the number of sides, and then that's going to give us the even angle between each of the circles. And then we're going to multiply it by I so that we can place it at the right location. And then we're going to use an ellipse function that takes in a total of 4 arguments. The first 2 are the x and y coordinate of the center of the circles, and then the third and the fourth are going to be the width and height. How about we let's create a variable called dot size and set it to 10. Alright, so as you can see here, we only see 2 points here, and that is because the center of this hexagon is at the top left corner of this sketch, which is the origin point. So we want to translate that to the middle of our canvas, so we can use the translate function. All right, and before we move forward, let me change the color of these circles to black. All right, so now we have a hexagon. What I want to do next is actually to put these circles into a class, and I'm gonna call it dot. Let's come to this arrow here, click the plus sign, and then click create file. Let's call it dot.js. And then before we start writing a class, make sure that you reference the file by coming into index.html, and then copy this line of code, change the name of this new file to the name of your new JavaScript file. In my case, it's dot.js. All right, and then inside here, we're gonna write a class called dot, and then the constructor function will have this dot r set equals to radius r, and then this dot angle set to this angle parameter here. And then we're going to use trigonometry to calculate x and y again. So this dot x equals to this dot r times cosine of this dot angle, and then this dot y equals to this dot r times sine of this dot angle. And then we're just going to do the exact same thing. So we're gonna write a method called display, fill these dots with the color black, and then we're gonna draw an ellipse from this dot x and this dot y, and then we can just use the global variable dot size for the size. All right, okay, let's go back to sketch. Now, how about we create an array called hexagon, and it is going to be populating with these dots. So instead of drawing it inside the draw function here, we're going to start by creating these dot objects, right? And put it inside our hexagon. New dot. And so the arguments will be r, which is 100 here, and then angle, right? But then angle, we will need to calculate using this equation that we just did previously. And then now inside draw, all we have to do is we just need to call the display method. And we should have the exact same thing. Perfect. So next, what we're going to do is that we're going to calculate the intermediate points. So we're going to call one of these a hexagon structure, and each of them will have some points in between, and the number of points in between will be depending on which layer it is. So I'm going to show you just this particular one structure, and then we'll create it with a bunch of layers. So how about we start by let me actually comment some of these. So the first one here is creating a hexagon structure. And then the next thing that we want to do is that we want to be calculating the radius and angle of intermediate points. So to do that, first we're going to declare the number of points that we want to create in between each of these points. So how about we try with just 2, and then we're going to use a for loop to go through I equals to 0 to I less than points, I plus plus. So what we want to do is that we want to calculate a radius and an angle of these points. And so these points will actually be in between the 2 points of our structure here, right? So what we're going to do is that we're going to actually use a function called lerp, which stands for linear interpolation, and it takes in a total of 3 arguments. The first one is the first point, the second one is the second point, and the third one is the distance in between those 2 points. So we can basically just pick any point, but the points that I'm going to pick are actually going to be the first point and then the second point inside our hexagon array. So it's going to be hexagon of 0.x, hexagon of 1.x. And then the third argument will be the distance between these 2 points, right? Because we have a total of 2 points, what we're going to do is that we're going to cut this into 3 segments, right? So what we want to do is we want to do the denominator will be points plus 1, right? Because we want it to be 1/3, 2/3, and then 3/3 here. And then the numerator is going to be I, but plus 1, because I starts with 0. So it's going to be I plus 1. All right. And then same thing for y. So these 2 calculations give us the 2 points between this point and this point here. Now what we want is we want the radius and the angle that makes up this. So basically we're translating from Cartesian coordinates to polar coordinates. So to do that, how about we don't need let. We actually want to keep it inside an array. How about I call it intermediate radius and intermediate angle. So int r and int a. Int r of I. So what is going to be a calculation for the radius? Basically, let's say we have a point that is here. We want to find the distance between the middle point here, which is the origin of 0, 0, and this point, which is x, y. And we can find that distance actually using the built-in function dist. So we're going to do dist, and then 0, 0, and then x and y. And then now we get the radius of this intermediate point. And then for angle, what we want to do is that we want to actually use trigonometry, specifically the tangent equation, to find the angle. And we can use the built-in function atand, which the calculation will be y divided by x. All right, and then now we have the radius and the angle of the intermediate points, but basically we only have 2, right? So I will show you how can we get the positions for all of the intermediate points for all of the sides. So that's exactly what we're going to do next. So we're going to be adding the intermediate points to the hexagon array. All right, so to do that, we're going to start by using a for loop again. But I will actually start at 6 because there are a total of 6 points already in the hexagon array. So how about we set a variable called starting point and set it to sides. All right, so starting points, and then I less than. So how many of these intermediate points are we going to have? We're going to have the number of points times the number of sides, right? So points times sides. But because we start at starting point here, so we need to also add it to this. All right, I++. Now, what we want to be doing is we want to be adding new dots, right, into the hexagon array. And we're going to be providing radius and angle as arguments. So what are going to be those? Basically, it's going to be the int r, the values inside int r and int a, right? But what would be the index? Because right now we have only 2 points here, right? We're going to be defining a few variables. The first one, we're going to call it points per edge. And right now it is the total number of points, which we set as 2, right? And then the second one is point in edge, right? So point in edge, it starts with starting point to starting point plus points times sides, right? So we want to know if it's the first point or is it the second point, but there are going to be so many, right? So to do that, we basically need to do the calculation I mod points per edge. And this expression is called modulo, and it returns the remainder between the division of two numbers. So this or points per edge. So this divided by 2 will either give us the number 0 or 1. So we know that it's the first point or the second point. And then lastly, we need to know which edge the point is on. And we can do that by calculating I divided by points per edge. This will give us a decimal number, so we want to use floor, and then this way it will give us the number between 0 and 5, so we know which edge it's on. So why do we need to know which edge it's on? Because we need to be populating these two locations on all of the sides, right? So we're gonna basically just translate it on all of the sides. All right, so now inside here, we're going to be putting in intermediate R of location, point in edge, and then intermediate A of point in edge. And then inside here, we're going to be displaying not just the 6 points, but it's going to be all of the points inside the hexagon array. All right, so now we have 2 intermediate points, but I said before that we actually have a total of basically points times sides, right? Which is 2 times 6 is 12, right? But why do we only see 2? And that is because the angle here is the angle of the points on the first edge. So what we need to do is we need to also add it to edge times 2 pi divided by sides. Right, 2 pi divided by sides, basically just give it the location of basically the angle of which edge it is at, and then the edge calculation here tells us which edge it is. And I hope that works. Yay! All right, so now we have one hexagon structure. Next, how about we create a bunch of layers? So basically, right now, our hexagon is a 1D array. We're going to make it a 2D array. And we're going to start by, how about creating a variable called layers? And how about we set the layers to be 5? Let's create 5 layers. And now I'm going to be modifying a lot of these and make it a 2D array, starting with this very first one. So how about we do for let I equals to 0, I less than layers, I plus plus. Then we're gonna put this inside here, and then all of this will have to be j, 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 j. Oh, and then to make it a 2D array inside the outer loop here, we're going to make hexagon of I to be equals to an empty array, and then it's going to be hexagon of I and j. Okay, one down. This next one is going to be the same thing, layers. All right, so instead of setting points to be equals to 2, actually the number of points will be exactly the same as what layer it is at. So I'm going to set it equals to layers. We're going to change this to j. And then here, okay, first we need to also create the int r and int a array to be a 2D arrays, right? And instead of just doing hexagon of 0, it's going to be hexagon of I of 0. Same thing here. And then instead of points here, this will be I, and then this is in turn will be j. Nothing should be too confusing. I'm just basically creating a 2D array. So I'm creating an additional layer into all of these arrays. All right, so I and j here, I and j. Okay, as long as I don't make any mistake, it should be okay. All right, layers, I plus plus, and then we're gonna put this inside here. This will be j, this will be j, j, and then for points, it will be I. This will be j, this will be j. And then we just need to make all of these 2D arrays. Okay. All right, and then the last one here, layers, I plus plus, and I of j, this would be j. Okay, save and let's try it. Okay, so actually there are two things that are wrong. Well, looks like there are a bunch of things that are wrong, but actually the first thing that we have to fix is, let's see. So the radius here should not all be the same, right? Each layer should have different radius. So how about we start at 15, and then based on the layer it is, it's going to be incremented up by that. So r times I plus 1. Okay, that looks better. Let me see first if there might be additional things that I mistyped. ij, j. Points here should be I. Yay! Perfect, it actually works out now. Now we want this hexagon to move, and to do that, we need to go back to .js here. Instead of just displaying, we're gonna write another function called update. And basically we need to be updating the radius. So we're going to actually just copy and paste this, and then inside sketch, instead of just displaying here, we're also going to update it. And you won't see anything right now because we have not updating the radius yet, right? So that's exactly what we're gonna do. So the equation that we're gonna do is gonna be hexagon of I and j dot r, and we're gonna set it, basically we're gonna set it to a signed equation which oscillates between a value of -1 and 1, and that's going to give us the movement. So if we do signed of some starting angle, and that we can set as 0. And we're gonna add or subtract the current angle that we have. So how about we do add, and then we do hexagon of I and j dot angle. See what happens. And then we're going to also set starting angle as 0. And then outside of the nested for loop here, we need to increment it, right? Starting angle by, let's do, how about 0.01? And everything goes back to this point here. Why? That is because now we set the hexagon radius to this, right? We're going to write a conditional statement that says if j is less than sides, because the structure has a different radius, right? Then hexagon of I and j dot r will be equals to r times I plus 1, right? Else, and these are the intermediate points, hexagon of I and j dot r will be equals to int r of I and then point in edge, right? So this is basically the same thing as how we calculated previously. Let's try it. Oh, point in edge is not defined, so point in edge is I mod points per edge, and points per edge is equals to layers. Oops, not layer, it's I, and this is j. And we want the amplitude to actually be scaled to the radius that we have calculated for each of the points, right? So we are going to multiply it by that. Yay! Okay, I was like, what was I doing wrong? All right, and as you can see, it's not scaled in the way that we want. So what we want to do is also adding this radius to the entire sine equation. And basically this radius is the distance between the point and the middle point. And as you can see here, it's still not exactly the same as what I had in mind. And now we basically have to play with the scale, and the scale that gives it the look that I want is if I were to divide this amplitude by 2 and then multiply the first part here by 1.5. Not bad, not bad. All right, so how about we put a point in the middle here as well? So let's put it, yeah, here. Let's do ellipse at 0, 0, and then dot size. And we also want fill to be before. Okay, then we can change this to a variable called speed. I'm going to call it SP, and let's set SP to be equal to 0.0. Let's make it a little bit faster. All right, so we're actually going to be making a set of 3 hexagon patterns like this. So to do that, how about we put it inside a class first? So let's come to this arrow here again and create a new file. I'm going to call it Hexagon, and then make sure you reference the file in index.html the same way that we referenced this .js file. So Hexagon. All right, so class Hexagon constructor, and we're going to be also writing the update method. So it's a lot of copy and pasting, so let me start with that. Let's do, yes, all of these, and also this hexagon one too. All right, and let's just try to organize it a bit. All right, and then all of these lets will have to be this dot, right? This dot, this dot, this dot, this dot, and this dot. All right, and then for update, basically we're going to be, oh no, not in update. We need all of these inside the constructor function as well. But to keep it organized, I'm actually going to write a function called create hexagon, a method. And then we're going to be calling this method inside the constructor function. So we can just do this dot create hexagon. And then I'm going to make sure that I put this dot on all of the necessary stuff. So hexagon here, hexagon there. All right. Int R, int A, hexagon, int R, int A, hexagon, this and this. And the rest are global variables, so they should be good. Okay, and then for update, it is going to be this right here. All right. Then we need this dot.
A few moments later.
All right, and I think we're ready to create one hexagon. So let's go back to Sketch, and how about I call it H, and H is a new hexagon. And then now we just need to do h.update. Run. Ta-da! Okay, so now let's create 3 of them. How about I call this hex patterns and create it as an array, set num to be equals to 3, and then we're going to use a for loop to create the 3 objects. So it's gonna be hex patterns, right? Dot push, you can do dot push, new hexagon. And then inside here, we're gonna do another for loop. And then we're gonna do hex patterns of I dot update. Run. We only see 1. Why is that? Because all of these hexagon patterns start at the same location. So let's switch that up. So how about we put in an argument here? Let's do, what should we call it? It's the speed that we want. So let's do sp and let sp to be equals to num, but it's gonna be I plus 1, right? So each one is going to be faster than the previous one. And then now inside hexagon, instead of speed being 0.05 here, let's do sp and then sp here, but you'll see something. It's gonna go really fast. So how about we also multiply that by, let's call it step, to make it a little bit slower. How about we set step to be equal to maybe 0.6. Let's see, 0.06. All right, that's better. Let's make it a bit slower. Okay, so we're almost there. The last part is just to add some colors to get that mesmerizing look. So I'm going to start by actually creating another argument. Let's call it C. And then inside here, this dot C will be equal to C, so for color. And where we're going to be putting the C, we're going to put it inside the dot object as well. So this dot C, and where's the other dot one? It's here. Here, this dot C. And then because we put it inside the dot class, we need to go back to the dot class here and add C as the new argument. So this dot C equals to C. And then for fill, instead of filling it as black, we're going to fill it as this dot C. Okay, and now inside sketch, C will be, how about let's just try let C to be equals to color of, C equals to color of 255 0, 0. So it should be red. Okay, but we don't want all the same colors. And the color that we actually want is these colors, but now we have to change from C to C of I. But you say, that's not the color I was expecting, and you are correct. The color that we want, actually, what we need to do is that we need to change the blend mode to this mode called difference. So before the for loop here, we're going to change the blend mode to difference. Okay, be warned, it is about to be flashing. So if you don't want to see that, close your eyes for 2 seconds. All right, this is not what we want. So to actually not make it flash like that, we basically just need to put push and pop before and after. And actually not exactly sure why. So if you actually know the answer, please leave it in the comments, but it does work. All right. And I want to play with the parameters a little bit to get the look that I want. So I want the layers to be a total of 6 layers. I want it to separate each one, the radius separated by an increment of 20. And I want the step size to be 6. And then I want the color of the background to be 240. And as you can see, it's huge. It's bigger than the sketch. And what I can do is I can go back to Hexagon.js, and then inside these equations here, we basically just want to multiply it by a specific scale, which I will set as 0.55. Play around with the numbers, but that's the number that I want. And it is moving to the left, and I want it to move to the right. So basically what I need to do is I need to, instead of using the plus sign here, we're going to subtract it. And it's going kind of slow. I want to speed it up just a teeny tiny bit. So how about, no, that's slower. Okay, so here's my take on this piece, and it's a lot of calculations, I know, but I think it's much easier to understand now, and I'm so glad that I finally have it in a video form to show you one of my favorite pieces that I did 5 years ago. So I hope that you enjoyed and give it a try.